Hello everyone. KernelCI has passed the test. Now, what does that really mean? If you're not familiar with the project already, KernelCI is a system for testing the upstream Linux kernel and also for collecting results from other CI systems. And a year ago, it joined the Linux Foundation. So the first year as a member of the Linux Foundation has been quite successful for our first year. We still have all the initial founding members, member companies. They've renewed their membership, and there's been some good feedback overall. We've achieved a lot of the things we wanted to do for the first year. We've started running more functional tests, and we've engaged with many other CI systems via the KCIDB project to gather results together to collect some results into a common place. We've learned more about the kernel community's needs, so basically what the kernel community expects from a project like KernelCI. We've also improved how to maintain the project and how to have development workflows for the project itself to make it easier for new people to join in and contribute. One thing we kind of failed to do was to produce some stats about the impact that KernelCI is having on the kernel quality, and that is something we'll hope to do better, to start doing really in 2021 with some new metrics. Now we're starting to have more results. We can use the data to actually draw a real picture of the impact of the project. Joining the Linux Foundation has had a big impact on the project, of course. So now we have an annual budget from the membership fees, which we haven't been using too much yet, but it gives us an opportunity to grow the project in new ways. We also have cloud compute resources from Google and Microsoft Azure, so we're using that to build kernels, and we'll be using it to run more tests. That has solved a lot of the bottlenecks we had before. We also identified the fact that we need to keep running tests initiated by KernelCI itself, and that's what we call the native tests. But at the same time, we need to collect results from other existing CI systems into a common database, and that's the external ones are getting collected via KCIDB. Now we've also seen a growing number of contributors in the project from new horizons, new companies, new individuals, and that I think is a direct effect of KernelCI being more established and accepted as the project that will really lead the way for upstream kernel tests. So on this slide you can see what has happened in the first year of KernelCI as a Linux Foundation project. So it started in October 2019 when this was launched during Embedded Linux Conference Europe. It took a few months to set things up and organize the board and define how the project would work, and set up the budget and do things like that. So in the end we came up with a mission statement to basically explain that KernelCI is there to improve the quality of the upstream Linux kernel. That was mentioned at FOSDEM last year. And I can say that a lot of things have happened since then, and things have been going pretty much as we would have liked it to happen. So since then we've come up with a new a prototype web dashboard for the KCIDB project. That's where you can see the collected data from other CI systems as well as the native KernelCI ones. So that's running in parallel to the main web dashboards we have on kernelci.org. We then in March we started using Microsoft Azure servers for hosting all our services. So the main website and all the infrastructure was previously hosted by servers donated by companies interested in KernelCI, and now so it was always a bit. It was not very sustainable because we didn't really. It was hard to expand. And hard to maintain, and all the servers were a bit different. And then, having this really helped us with the Microsoft Azure servers to have a sustainable project. And then KernelCI had been doing builds and boot testing for a long time, and that was kind of the reputation of KernelCI, that it was like boot testing. Now, in April and May last year, this started really to change when the web dashboard on kernelci.org was improved to show functional test results and not just boot results. And since then, we've kept adding more and more tests to the native test systems. Then in May and June, we conducted a community survey to learn more about the kernel community and how to really address the needs of the kernel community. I'll come back to that in detail a bit later. And then we started using Kubernetes for doing kernel builds, so using cloud VMs from Google Compute and Microsoft Azure, and this has really helped scale up the build capacity. And we're planning to also use that to run tests that don't need a physical platform. Then in August there was Linux Plumbers 2020, and that was a really important conference for KernelCI, being the main upstream kernel conference. And we could really see that KernelCI was in a lot of people's minds, and it came up in many different topics. Of course, there was a testing micro conference, so it was very present there, but also it was present in real-time discussions. And since then, we've actually, during the week of Plumbers, we started running real-time tests in KernelCI. It was also mentioned in tool chains, so we've improved. We're also doing during Plumbers, we improved how we test building the kernel with Clang and LVM Clang. We also discussed how to improve KCIDB test support and many other things. So KernelCI was really present almost everywhere. Not really as a main topic for Plumbers, but you could see it was becoming part of the community in a real integral way. And then after that, also we started receiving results from Google Sysbot into KCIDB. That was really an important milestone because it was the first real external contributor to KCIDB. Initially, we had CKI, which started from Red Hat, which started contributed right at the beginning of KCIDB, since KCIDB was to a large extent a Red Hat project, but also the KernelCI native tests were being added to the database. So having Google Sysbot was really a big milestone to show that we could also have other CI systems contribute to KCIDB. Since then, we've made good progress with others as well, and that was in September, so it's already a few months ago. I wanted to just focus on the first year, but things have carried on happening since then. So basically, we have a growing ecosystem, and by ecosystem I mean the kernel ecosystem, as well as all the things related to testing around the kernel. So we can look at it from the point of view of what testing actually is being done on the kernel. So that's what we can call the kernel testing landscape. It's very segmented basically. You have individual contributors, individuals like developers and maintainers, who would run their own tests that they've defined themselves typically. Or if they are part of an organization, it might be the test system from their organization. But they'll do what they have at their own disposal, what they have locally. And basically they will tailor this to really match their needs for their day-to-day work. Then you have organizations like distributions, OEMs, and SoC vendors. So these in this case is the kernels will be tested in a more extensive way, but also in a more vertical way. So it will be testing only with distro kernels, for example, and the test will be pretty much trying to test the features of the distro or of the product if it's for a phone manufacturer or a server provider. There'll be, or whatever uses Linux. Linux is tested all the time on all these products, but in a very specific way to make sure that the product works, not just the kernel. And similar things happen with CPU vendors and SoC manufacturers. Slightly lower level, but still they make sure that it works on their platforms. And of course, all these things make sense for each individual organization, each individual developer. But none of these are really testing the kernel for what it is or in its entirety, and that's not really possible either. But then you have some more general projects like Intel 0 Day, which try to build and test all the kernels. So there's many kernel builds are made by Intel 0 Day for different architectures. And basically it's about building and testing patches from mailing lists, which is really helpful and provides a really short feedback loop. But the actual tests are typically only run on Intel x86 because it's an Intel project. So that's what makes sense for Intel and the platforms they have and the focus they have on. Then you have a different way of testing the kernel in a general way with fuzzing, so like syscaller and the syspot service. That's it's about fuzzing the kernel with system calls. So it's a very generic way of testing any part of the kernel. But on the other hand, you can't do just that. You also have to do functional testing to find different kinds of problems. So all these things all add up basically to the full picture of whether a kernel is good or not, and pulling them together is what the mission of KernelCI. Now this picture, I guess it's a familiar typical example of what test-driven workflow really looks like. But I think for the upstream kernel, while some of that is happening, I think it's not really part of the kernel development itself. It's more like a asynchronous system where you have the kernel development happening at its own pace, and then you have some test systems working in parallel at their own different pace. So for example, you have contributors who contribute to the kernel code and to the tests to some extent, and in some cases both, because KCIDB and KUnit are hosted directly in the kernel tree. Then when new changes are made, of course you have the infrastructure building kernels, building the test suites as well, and running the test and processing the data, and generating reports, finding regressions, all that kind of processing, and then sending notifications by email and web dashboard to the contributors. Now what you can, in an ideal CI system, a change would need to pass some tests before it's accepted, before it's merged in the main branch. And we don't really have that in upstream kernel at the moment. So I think maybe for stable releases, there's an implicit expectation that because you have some systems that test stable kernels and they send some reports, so you would expect normally for stable release to have actually waited for the results to come in before the release was made. But I don't think there's any written agreement about that. You don't have a stamp on each kernel release to say this has passed all these tests. You can only assume it's the case. So if one CI system was was down, was not, or disappeared, or for some reason stop testing a stable branch, I'm pretty sure the stable release would happen anyway. Maybe there would be some questions like what's going on, but it wouldn't be blocked by that. Unlike, if you use GitLab, for example, you set up the workflow so that each patch has to pass some pipelines, pass some tests before it gets merged. Then if you don't have tests, you don't have, the patch is not merged typically. That's a hard requirement, and we're quite far away from that in the kernel development. And it's especially true for the changes that land in Linux Next, or even in mainline during the merge window. Basically, the expectation is that everything gets thrown together, people will test it at their own pace and report problems, and gradually with each release candidate you would expect less people to report problems, or all the issues to have been fixed. But in the end, you don't really have a positive confirmation that things are working well. You just assume that because nobody's reporting any issues anymore, that it should be fine. And I think that works because nobody is really using directly a mainline kernel or even a stable kernel in a product, so then people will be testing that anyway as an integrated product, not just for the kernel itself. And basically having the quality, some quality metrics directly from upstream kernel and stable releases is what KernelCI is about. So then that means it would remove some duplicated efforts for all the OEMs, all the people, or even distros, all the people reusing the kernel in a real environment. From it would remove some of their testing effort, because they could already rely on what has been tested upstream. That's something that can't really be done right now. So then, to understand a bit better how to make KernelCI work for the community, we made a survey. So, as I've just explained what the ecosystem is basically all the different players interacting with each other. So, people contributing, maintainers, and people using it in products, people making tests. But all these people are part of a community. So the survey showed some interesting results. So the main takeaways are that we should be trying to test patches more, or start testing patches with native tests, because right now all the tests on KernelCI.org, all the builds, even on KernelCI.org, are only there because a change was pushed to a Git branch. So we're monitoring a number of Git branches. When there's a new revision, it gets built and tested. And that works for a lot of things, but we're missing a lot of the early stages when a change or even a patch series is being sent to a mailing list. That's when the first review is being done, and having it tested at that point by KernelCI would add a lot of value. Also, it would be easier to report issues, because we know the people on the thread would be notified of the results. When by comparison, when you have a regression in mainline during a merge window or on Linux Next, you have a lot of changes being merged all the time in these cases, and so you don't really know which individual change caused the problem. So if there's a regression between yesterday and today, you don't know who to tell that there's a problem. So you can guess based on what test failed, and you can do bisections to find the actual commit that caused the problem, and that's the ideal case, because then you know exactly who to send the reports to. But that happens kind of later, and it's like a medium feedback loop. We need a shorter feedback loop for the early stages of development. And then we also need longer running tests for having a long test feedback loop to be able to do things that individuals can't do themselves, like running really extensive tests that take days on a huge variety of platforms. So these things, we can do them for like RC tags or stable releases, because they don't get updated that often, and it's really important to know. The idea is that these versions should really work as well as possible, so that's why it's important to test as much as possible. and that's after the initial reviews have been done. So I think Sysbot is contributing to that, is helping address this part of the problem, because fuzzing is a long-term, it's long-running tests. They are not really, the results are not really part of the short feedback loop you get with sending patches, but things like that, things will be discovered later. But it's also something we should be improving with native tests. Like we could be running more LTP or maybe KCL tests on a huge variety of platforms. That's something to explore. And the third main takeaway from the survey was to improve the web dashboard. Even though a lot of the workflow for kernel development is done around emails, we found that a majority of people also would benefit from a web dashboard that would give them the information that they need. The current dashboard is quite static, and we found that there's many different types of people who need to see the data in many different ways. And without having a flexible way of doing that, or a more precise idea of what people really want, the kind of the scale at which people want to be able to customize what they see on the dashboard, without having that, we can't really have a good dashboard. So what we have now is a minimal version that helps, that works to some extent, but we're collecting user stories to try to understand better what an ideal dashboard would be, so that it would really solve the people's problems, so it would be a really useful tool. So yeah, we're trying to have this more like data driven, based on the feedback from people. So if you send us your feedback, we'll have an idea, we'll work with UX designers to find out the best way to have a tool that works for people, and then we'll work on implementing it. And of course, having then more feedback later when we have something to show would be really helpful as well. So how does it work? How does KernelCI work? Now we've explained all these things, maybe I think it's important for people to have an idea of how it all fits together, so that you can then contribute and then take part in it, or maybe suggest ways to change it. So like I've explained before, you have native tests. These are orchestrated directly by KernelCI. They are normally running in Lava test labs, but not necessarily. They can also be running in other types of labs. We have a couple of other types of labs. You can also have tests running in Kubernetes for like static analysis. So all these tests are using the builds produced by KernelCI, and the results are being sent to the KernelCI backend, and you can see them on the KernelCI frontend and on kernelci.org. And emails are being sent with the results for that. Now, we also have the KCIDB database, which collects results from other CI systems, other complete CI systems that do their own builds, run their own tests on their own platforms. It's all, they work within, they work on their own, but they then submit the results they have to KCIDB. So CKI has been doing that since the beginning, and we also have Google Sysbot. We also have the native test being added to KCIDB, and we have an increasing number of them, which I'll come back to that a bit later. So what are the native tests? What's their nature? So first you have the baseline tests, which are basically like boot tests, but a bit more. So they boot to a login prompt, and then they check for kernel errors, and they run the boot RR test suite, which has a series of checks for each platform to verify that the right drivers are loaded and devices are probed and things like that. That's run on all the platforms, run on with all the kernels, basically all the possibilities for the native tests. So all the labs connected to kernelci.org will normally run baseline on all their machines. Then we have some custom written tests, like the sleep test, which is basically suspend and resume using RTC wake. I suspect this is similar to what some maintainers would have designed for their own personal workflow, or their own local test system. So if that's the case, if you have a test like that that you think would benefit others, you can have it. So you can submit it to KernelCI. We can add it to the native tests and have it run more widely. Then we have more classic test suites. Well, we have V4L2 compliance. That one we've been running for a while now, with UVC video, for webcams on a variety of platforms, and also with the Vivid driver with QEMU. We have been running some parts of IGT for the FOSDEM 915 Intel GPU drivers, and also for some display drivers, DRM KMS drivers. We more recently started running LTP tests. Now, as you know, LTP is a very big framework with a lot of tests. So we've identified about 35 subsets of LTP that appear to be relevant to KernelCI because they exercise some part of the kernel, and we have like 2 or 3 in production now. So the IPC and crypto, I believe. Well, some of them are being worked on, so they're running only on the KernelCI staging instance, and they'll be deployed in production when they're working well enough on a number of platforms. So we'll keep growing that, keep growing LTP support, and hopefully we'll have good share of these 30 or 40 subsets of LTP by the end of 2021 if we keep at that pace. And similar story for K-self-test, although it's we started about the same time, around the same time, but it's a very different test suite because it comes with the kernel. It's built in a very different way, so we had to fix some issues with how to build it initially. So we've done that now to separate the K-self-test build log from the kernel build log. And also now we're starting to look into how to run subsets of K-self-test, especially because K-self-test tests are more likely to cause kernels to hang or to crash or to have side effects that would make subsequent tests to fail or not run at all. This is especially true for K-self-test more than LTP or other types of user space test. And so we're still preparing all these different things to make it more reliable as a test suite to run and build. So a lot of work has been done already, and we don't yet see the results because we're adding all these different bricks, and at some point we'll be able to turn the light on, and then we'll have a lot of results coming. So it's different in that respect from LTP, because LTP we have some results very early and we keep growing it in a linear way. With K-self-test we have this kind of threshold moment at some point where we'll suddenly have a lot of results, hopefully. And then there's many more in the pipeline, like I've mentioned before, KUnit and cyclic test for real time. Basically any test that exercises the kernel is a valid test. Whether the main KernelCI team of developers works on enabling it, or whether it's a maintainer, or whether it's someone else, that it's important for us to accept. We make it easy for other people to contribute their tests. So in order to scale, we need to be able to accept tests from other people as well. But then one of the main one special feature about native tests is that they can be bisected. We can have an automated bisection run for them, because KernelCI orchestrates the native test. It does the builds, it runs the test and collects the result. You can then do that again for a different version of the kernel, just run one test, and that's what bisection does. So for every KernelCI native test result, we're tracking whether they pass or fail. And when a test used to pass and one day it starts failing on a branch, or with one revision it starts failing, then a regression is recorded in the database. And normally an automated bisection would be started for that regression. Now we have a range, like a good version, a bad version. on a branch, and we know the architecture, the compiler, the platform, all these conditions. So basically, we can run a bisection for that. And now a few checks to remove false positives, remove duplicates, and when all that works, then you have a bisection email report sent to the KernelCI results mailing list. That's a result we use to moderate the reports, because we still want to avoid having the same results sent multiple times. Typically, when there's a problem and a fix has been made but it's not merged yet, or it's on a branch that hasn't been pulled in Linux Next, or for any reason, it can happen that the issue is known to be fixed and still the regression is still present. So basically 90% of the work is automated, and we have this extra manual work at the end to make sure that we don't cause too much noise with the email reports. That's something we can work on improving now. We have better support for tests as well. And currently, this currently leads to about 1 bug fix per week in the kernel. So sometimes a patch will be reverted or dropped or rewritten, or a fix will be added. Every bisection will lead to a different story. So I've added 3 recent ones. I've added some links to some mailing list discussions for 3 recent ones, just to give you an idea of what that gives us. So now you know a bit better how KernelCI works, what it does, its purpose, how it all fits together. How can you take part in KernelCI? So in the same way that the Linux kernel is a big open source project, it's following the open source philosophy, and it's one repository that can be built in many ways and works for all the people using the kernel. So it works on small devices, big devices. There's one upstream kernel. In the same way, we want to have one KernelCI to be able to test that whole kernel. Of course, that only works in the same way that open source works. You have many different contributors who care about their own use case and come together for one source project. So for KernelCI, the idea is to have all these different ways of running the kernel being tested in all these different matching ways, and have all these tests being pulled together in what we can call open testing philosophy. So we don't just use open source, but we also pull together the different hardware that's being used for testing the kernel, the different test definitions, and we group the results. And also it has to be driven by the community, like for open source design. It's the not just the license of the code, but it's the whole approach to how the system is designed. So that's why it's important for members of the community to take part, for the project to really succeed in the long term. So there's different ways to contribute. You can contribute test results. So if you have, as an individual or as an organization, if you have some platforms you want to use to run tests, to run KernelCI tests, you can set up, for example, a Lava lab and have it connected to KernelCI to run the native tests on it. So that will include things like the baseline tests. You can have IGT run on it, LTP and KCF tests, and all these native tests. You can have them easily run on your platform if you create a Lava lab. If you already have a way to automatically run tests, to automate tests on some platforms, and if it's not Lava, you can also connect it to KernelCI. We have a couple like that already. And then if you have a full CI system where you already make your own kernel builds and you run your own tests on your own platforms and everything is integrated and it works on its own, you can submit the results that are produced by your CI system to the KCIDB database. So the KCIDB database is used for common reporting. So the final goal is to have one web dashboard, which would be like a superset of what we currently have, to show the results from the native test, but from all the other CI systems that report to the same database as well. And then also send a common email report on the mailing lists to have a complete picture of how one kernel revision has been tested, for example. We have a number of contributors or submitters already, like CKI and Syspot, like I've explained before. So if your company or if your organization has that, it could be a Linux distribution, it could be an OEM, it could be anything. Typically, we need to be upstream focused, but the rules for that are a bit more flexible than for native tests. For native tests, we're only monitoring upstream branches like maintenance branches, stable, next, mainline. For KCIDB, you can be building a distro kernel. So I think like a real downstream branch, like from a complete integrated product, would be maybe not too useful, but it depends. It's not every test result is useful to some extent, because then we can compare things. So if you run a product that's, if it's an Android phone with a 3.18 kernel, for example, we can compare that with the current 3.18 version. That's, kind of an extreme example. But having extra data from real products can also be useful. And it's not something KernelCI native can do. But there is some data, some testing being done to a large extent out there. And KCIDB can help convey all that data into one place to have added value. Then you can also contribute to the project more directly so you can submit your own test suite or test plan definition. So if you like I've explained before, if you're a maintainer, you have your own set of scripts to test your part of the kernel. If you think it's going to be useful for other people, you can submit it, and we can add it to the native tests of KernelCI. There's a manual about a user guide about how to do that now. You can also contribute to the core of KernelCI, so like extending the build coverage. That means maybe creating new Docker images with tool chains to build for a different type of architecture. It could be all kinds of things like that. Improving the pipeline. So right now we're using Jenkins for the native tests, and we want to start using our cloud resources more with Kubernetes. So maybe, there's Jenkins X, I suppose that's one thing, but also we're looking into using newer technology like Tekton and maybe other types of frameworks to really make the best use of our cloud resources. And also, just if you try to set up your own instance of KernelCI, you try to use it, you'll be relying on the documentation. And if you see any problem in the documentation or any gaps or problems or mistakes or whatever, you can try to help improving it. So for all these things, you can get in touch. Or if you're not sure, you can get in touch. If you have any topic you want to discuss, you can get in touch with us on the mailing list, KernelCI@groups.io, or on IRC, KernelCI on Freenode. It's also, of course, possible just to send a pull request on GitHub. Or create some issues. You can also have issues to say, I want a new branch to be monitored, things like that. So what should we expect in 2021? So the project has a technical steering committee, which was defined as part of the Linux Foundation project setup. Now in 2021, we want to have it better defined, to actually define roles. So some people will be in charge of the services being run, of the cloud builders. Some people will need to be in charge of the documentation, of responding to requests on the mailing list. There's a number of things like that we should identify and document, and then we would have points of contacts for each of these things to be more clear, more transparent about what the project is, how the project actually works from a practical point of view. So we should have all these documented in a public way. It's really like a maturing phase for the project, and also that would make it easier for the community to contribute. So it's about empowering the community to know where to start, to be able to add a test or whatever needs to be done, to basically keep the project evolving hand in hand with the community. And here I've just listed a few things that we could be doing in 2021. There's an infinite number of things. Some of these things will be done by the current main core KernelCI developers team, and some of the things could be done by additional developers, members from the community. And there isn't a clear border between these things. It's more like people frequently contribute. It's like in any project, you have, like any open source project, you have the core contributors and people who gradually contribute less and people who contribute just occasionally. So all this combined together, basically we have a list of things that would seem the most important ones. But of course, if you have something to contribute because it's important to you, there's no reason why that can't be done. So we've started doing running KUnit with Brendan Higgins from Google, and Heidi, who's an intern as well. So they did like 80% of the work. It's not yet in production. That's something we would like to complete. We also want to run more static checks, like device tree validation. We had Isaiah as an intern from Microsoft who did again a great share of that work, and needs to be completed. And running spars or whatever standard static analysis can be done on the kernel. We also want to continue working with Pangotronics and other people about having better support for LabGrid, to try to make it as easy to use LabGrid as Lava with native KernelCI tests. And the other things I've already talked about in this talk. So we want to gather some user stories for a better web dashboard, redesign the pipeline using cloud infrastructure. We want to improve automated bisection and keep extending what we're already doing with better build and functional test coverage, and more maintainer branches for all the native tests, and also having more KCIDB contributors. So this is basically all the things that we should be taking care of. And of course, testing patches is also something that's important, but it will mean more changes in the way we work with KernelCI, so that might come a bit later in 2021. Still, we know it's an important topic. So thank you for watching, and I think now we can have a live Q&A session. So on this slide, I've put a few links and pointers to get in touch. So with the mailing list, GitHub, and IRC. Thank you very much.